Hello and welcome to Tiny Code Christmas Day 2. 12 days of size coding and demo scene effects for fantasy consoles. If you've just joined us, don't forget to check out Day 1 and the tcc.lovebyte.party website for more information. We're going to start today with Tick 80. If you're here for Pico 8, you can skip ahead. Today we're going to take a look at time. So the first thing I'm going to do is type help time on the command line and take a look at the time function. This function returns the number of milliseconds elapsed since the cartridge began execution, and it says it's useful for keeping track of time, animating items, and triggering events. So first thing I'm going to do is clear the screen, and then I'm going to assign time to the variable t. This will save us space if we want to use time in multiple places throughout our code. We can simply refer to it as t. So this gives us the time in milliseconds, and I'm just going to print out the time. So this is the print function. We haven't used it before. I'm going to give it t, the number that I want to print out, and I'm going to give it a 0, 0 coordinate, so top left hand corner, and I'm going to give it 12, which is the color white. So I'm going to run this, and we should see the number of milliseconds ticking by, and you can see it's a floating point number, so we have a lot of accuracy available to us if we need it. So if we need to get the time in seconds, we can divide that by 1000. And if we want the time in whole seconds, we can use an integer divide. That will give us the time in full seconds with no value after the decimal point. So when we're working with our demos, oftentimes it's nice to work with real seconds, but generally you'll be adjusting this based on how the effect looks or feels. So a lot of the time it's not an exact science. So now I'm going to use time to animate something, and I'm going to use the pix function, which will allow me to set an individual pixel, and I'm going to set the x coordinate to 10, the y coordinate to 10, but I'm going to add the time to it, and I'm going to set the color to 12 as well. So when we run this, you'll see here's our little pixel dropping down the screen, and every number here, the y value increases and our pixel drops further and further down the screen. And I can change this again to be different speeds, and you'll see the difference that makes. Another method of working with time is, instead of using the time function call, is to add 1 to the variable t each time tick is called. So I'm going to initialize t equal to 0 up here outside of the function, so that happens when our cartridge loads. And then every time inside here, I'm going to go t equals t plus 1. And now, when I run this, you'll see my animation is very smooth, and we're updating at 60 frames per second. Tick is called 60 times per second, and that adds 1 every time tick is called, so we can see that is progressing, and we're printing out t in the top left still, so you can see that value and what it looks like. So that's the basics of animation, and that is essentially a single snowdrop that we're after animating. So now I'm going to load yesterday's challenge. So you can see here, this is my challenge from yesterday. I cleared the screen to color 8 to get it nice and blue. I drew a rectangle for my tree trunk. I used a for loop to draw several triangles, and I used a rectangle to draw the grass, and I used a circle to draw the star on top. And when you draw a circle with a fairly small radius, you get that star kind of thing. So we have our for loop drawing 5 triangles and a bunch of rectangles and a circle for the star. So you can take a look at that code there. So you can see we're at 245 characters including comments. I'm now going to remove the comments and see that we're well within size at 185 characters. So what we want to do to this scene now, since we're talking about time and animation, is add a bit of snow. So to do this, I'm going to use a for loop, and I'm going to make it count from 1 to 100, and that is going to be used to draw 100 snowflakes or 100 drops of snow on the screen, and each one is just going to be a single pixel. So I'm going to use the pix function, and I'm going to set the x coordinate to be I and the y coordinate to be 10 and the color to be 12. So at the moment this is just going to draw them all in a straight line, all on the same y coordinate and in the color white. So what we need to do is break these up a bit, and I'm maybe going to multiply I by 20, and when we run that now we'll see that it has in fact spread those out a bit, because now there is 20 of a gap between them. And what I can do is I can use mod by 240, so that will take anyone that goes off of the end. So you'll see there's none here, and if I put back in the mod 240, there is one here now. And what that means is that if this value goes above 240, it will be brought back down. So it's the remainder after dividing it by 240. So if it's 241 mod 240, it'll be bring it back to 1. And 240 pixels is the width of the screen in TIC 80. So we can do something similar with the y coordinate. So you can see here I'm after spacing them out a bit, and it gives them a bit of a sloping effect. And I can try a few different numbers and see what happens. But what I need to do with this also is add in a modulus, so that when we get to the bottom of the screen, that the snowflakes will wrap back up around the top. So if I remove that, you see there's no snowflakes up here, and if I put it back in, you see there are snowflakes up here, and that's because they've gone down off the bottom of the screen, been modded by 136, and they're back up at the top. So we can make some changes to this to try and make the snow a bit less uniform looking, and obviously we'd love to initialize an array and have it randomly generate all of the snowflakes, but that would take a lot of code. And you can see here we're still under 256 characters even with our snow. So I'm going to change this to something like maybe 57 and 4, fairly uniform, but it looks nice. And I think something like 2 or 3. So you can play around with that and see what you prefer. Now your challenge for today is to take this code, take what we learned about time, and animate that snow. And the challenge again for today is to keep it under 256 characters. And don't forget to check the website for some additional expert challenges. Best of luck. So today we're going to take a look at time and animation. So the first thing we're going to do is we're going to go help time, and we're going to see that Pico8 has a time function, and it also has a smaller version of it with just t that returns the number of seconds since the program started running, taken from the moment the current frame started. So this is going to give us the time. I'm going to store this in a variable called t for now, and that will mean that anywhere that we want to reuse the time, since it's not going to change during the frame, we can just use t instead of using the full function call for time. So I'm just going to clear the screen, and I'm going to set t equal to time, and I'm just going to print it out to the screen. So I'm going to print out the value t to the coordinates 0, 0, and I'm going to use color 7, which is white, and that print function will print a bit of text or a number to the screen at these coordinates in this color. So I'm going to run this now, and we can see up here in the top left hand corner we have our time, our number of seconds, and we can see that it's a floating point number, so we do have a little bit of extra information there instead of just the whole second. So as it said earlier, there is also the t function, which is just a shorthand for time, but if I'm using t as my variable, that will cause a conflict. So generally, if you want, you would use t directly like this, or you'll have to assign it to a different variable. So I'm going to change this back to t equals time, and now I'm going to do a very basic animation. So I'm going to use the pset function to draw a pixel at 10, 10, but I'm going to animate this by adding time to it. And I'm going to color this in with 7 again. So if we take a look at this, it's going to put a pixel at 10, 10, but it's going to be 10 plus t, so the y coordinate will be based on the time. So we can see that's falling down fairly slowly there, as it's 1 pixel per second. So we can mess around with this and change the time value, maybe by multiplying it by 60 or something like that, until it feels right. A lot of the time when you're working with animations and timing, it's going to be down to what looks good as opposed to an exact science. And I can change this to a different value, and we can see how that works. So we're after animating a single snowflake falling from the ground, and what we're going to do now is load the challenge from yesterday, and we are going to add snow to it, and your challenge will be to animate it. So let's load day 1. So this is day 1 loaded, and since we'll be dealing with limits that are character based again, just down here I'm going to change to character count, and we can see here if I run this, I have created a very basic snowman, 3 circles, each one getting bigger as they go down, 2 eyes, the ground, and a blue background. Not earth shattering, but enough to give you the idea. So I'm just going to remove these comments. Let's see that we're at 138 characters, so we're still well under the 256 limit for this. So I cleared the screen, I set up a for loop that went from 10 to 60 in steps of 20, so 3 times, and I drew a circle, and it uses the I divided by 10 to alter the radius of the circle, and obviously the color is 7. And then I set 2 pixels for the eyes, and I set a rectangle filled for the ground. So now we're going to add some snow, and I'm going to set up 100 snowflakes, and I'm going to use pset to draw each one of them. So I'm going to set these so that the x coordinate is I and the y coordinate is 10, and that the color is 7. So if I run this, you'll see that we have some snowflakes up at the top. They're all in a line, which isn't ideal, but we're going to work on that. So obviously the ideal solution, if we weren't doing size coding, would be to declare an array and give position for each one of these snowflakes and alter them as time goes on. But since we're size coding, we don't really have a lot of space for that. So I'm going to maybe multiply this by 20. And if we run it now, we'll see that we've spaced them out a bit. And they will continue off of the screen. So what I'm going to do is I'm going to mod each of them by 128. So 128 is the screen width for Pico 8. So if one of these snowflakes is too far to the right outside the screen, it'll wrap around back, and we can see that that is exactly what's happening. And I'm going to do something similar for Y now, and I'm maybe going to multiply it by I and see what happens. Okay, so we can see them dropping down. So now I'm going to mod it by 128, which is the height, and we should see that they wrap back around. So I'm going to change this value to 2, maybe 3. See what it looks like for different values. And now that we've set up the snow, your challenge is to animate it. And again, you can play around with these values. It's more art than science. And keep the animation inside in 256 characters. Now hopefully you pushed yourself yesterday and got up close to that 256 byte limit, so you might have to make some adjustments today to fit in the extra code for the animation. So best of luck, and don't forget to check the website for the expert challenges. Don't forget to come back tomorrow for the next challenge, and if you have any questions, check out the Lovebyte website.